Good afternoon, everyone. I want to welcome everyone to the Building Energy Education for Architects, or our B for Architects. Today, we're going to be touching on the significant changes moving from the 2018 IECC over to the 2021 IECC. Before we begin, I do want to have two guests today joining us from the AIA Illinois and the Illinois Green Alliance. So Eric Klinner from the AIA Illinois, if you'd like to say a few words before we begin.
Good afternoon. Thank you, Ryan. My name is Eric Klinner, and I'm the Managing Director for AIA Illinois. I'd just like to welcome everybody to the first of 3 Building Energy Education webinars that we're excited to be a part of this spring. AIA Illinois is excited to be offering this series again in conjunction with CDAC and in partnership with Illinois Green Alliance. Now I'd like to welcome Juanita Garcia from the Illinois Green Alliance.
Thank you, Eric. As Eric said, my name is Juanita Garcia, and I'm a Senior Project Manager with Pepper Construction. And I also have the pleasure of serving on the Board of Directors for the Illinois Green Alliance. For those that may not be familiar, Illinois Green is a membership-driven nonprofit that works to promote green buildings and sustainable communities for all. Our vision is all about bringing net zero technology and design best practices to every building in Illinois through professional education, policy so we can scale the impact of high performance design, and community service projects to show that high performance and net zero building techniques are affordable and feasible anywhere in Illinois and in any building type. Every year we host more than 75 education events, building tours, and community service engagement opportunities, like the Illinois Green Schools Project. To deliver so many events every year is only possible thanks to partnerships like this one with AIA Illinois and CDAC. As a membership-directed organization, our members drive the content of our education programs and lead in helping with our projects. For example, last month we hosted a building tour and education webinar focused on all-electric residential building on Chicago's South Side, and an upcoming program led by our education committee titled Low Carbon and High Wellness. It'll focus on the needs of workers returning to the office. I hope you'll consider getting involved either by attending an upcoming event or by lending your time or expertise to one of our events or programs. To learn more about upcoming education programs, I encourage you to visit our website at illinoisgreenalliance.org. And thanks again to CDAC and AIA Illinois for hosting this event and partnering with us on the program.
Well, thank you so much, Juanita. And see, there's a couple of questions coming in towards the bottom of your screen. There should be a Q&A pane. So if you do have questions, please feel free to go ahead and use that during our presentation. I'm Ryan Siegel. I'm joined today by my colleague, Robert Schlorf, here at the Smart Energy Design Assistance Center. And today's webinar is being recorded, and the recording along with the slides will be posted to our website. We'll talk a little bit more about that a little bit later. We are also an education provider with the ICC and AIA. Everyone attending today's session will receive in their email a certificate of participation. And for those of you during your registration that provided your AIA membership number, those we will also file on your behalf for your CEUs. Today's workshop, we're anticipating to take approximately an hour and a half. And we're going to be touching on a lot of the changes moving from the 2018 International Energy Conservation Code to the 2021 version of the International Energy Conservation Code, which is the basis of the Illinois Energy Conservation Code. So a lot of IECCs here to deal with. So also looking at some of these the challenges, and understanding the compliance. We're also going to be touching on some of the anticipated Illinois amendments for that. Illinois is in the process of updating, and so the amendments have not yet been totally finalized for that. A little bit of background about who we are. Smart Energy Design Assistance Center. We're housed at the University of Illinois and our applied research program here. And our primary mission is to reduce the energy footprint both in the state of Illinois and beyond. And these training presentations are one mechanism we use to accomplish that mission. As was mentioned earlier, today is a first in a series. So we've got one today in March. We also have one in April and another in May. So for April, we're going to be looking at the upcoming 2022 Chicago Energy Transformation Code, which became in effect November 1st of 2022. And then for May, we're going to be looking at both the Base Energy Code, Illinois' upcomingly available Stretch Energy Code, and the Chicago Energy Transformation Code. The Stretch Code will be available for municipalities and jurisdictions across the state to either adopt or remain with the Base Energy Code. So good to be aware of what makes some of those differences, particularly for designers out there who even if they are working on a project that's in an Illinois base code jurisdiction that may wish to help encourage their clients and incorporate some of the more stretch design features in their projects as well. So do hope that everyone will be able to join us for those. Our energy code has a fairly broad technical support program. So if you do have any questions regarding the state energy code, be it as a design professional or even projects that you're working on, be it contractors, code officials, or even building owners and occupants, they can use our technical support helpline. Email address energycode@illinois.edu. We also do have an 800 number. So if you do have just a quick question about, where would I find this in the code, you can use that 800 number. We do encourage people to use that email address, again, energycode@illinois.edu. That allows us to provide you a written response and allows it to be a little bit more thorough. People do generally like to have that written response. That way everyone can be reading off that off the same sheet of music, so to speak, because oftentimes we'll have projects come in and there's questions between the design team and the contractors and the code officials such that everyone can have the same information as part of that. Do have several online resources at our website, smartenergy.illinois.edu/energy-code, including upcoming and past versions of our archive copies of our workshops and webinars, along with several online on-demand training modules. So one of the big questions is, when is the state of Illinois going to be moving to the 2021 International Energy Conservation Code as the basis of the Illinois Energy Conservation Code? That is anticipated to be coming this summer, 2023. It's been delayed a bit, but we are anticipating the first reading of that will be going to the Capital Development Board for their vote on that at their April meeting. So that will be coming up here. So adoption. So for projects, understanding which version they are going to be under at this point in time. This is based on the permit application date. So with this being adopted and enacted this summer, so if you have projects that are not yet in for permit, but you would like to stay under the 2018 version, go ahead and get those in for permit. Hopefully, because this will be coming in the summer, so that'll be during peak construction season. Hopefully you're not going to be trying to permit something for construction this summer and waiting till late in the summer to permit for that. So that will be coming for that later this year. Mentioned a few things about our website where you can find upcoming and archive versions of our previous workshops and webinars, along with our online on-demand training. These courses are designed a little bit towards the beginner end, so you don't have to be specializing in codes or particularly the energy code to be successful and have a good learning experience from this. So written more for a beginner in mind. Again, we also link back to our technical support helpline. So if you do have a difficulty remembering our email address, again, energycode@illinois.edu, you can go there. Also have links to several other resources, including links to the current version of the Illinois Energy Conservation Code, the Chicago Energy Transformation Code, some information on the upcoming Illinois Stretch Code, along with links to that when they become available. We also have several frequently asked questions. So if you do have a question that you think might be a typically asked, go ahead and you search under that frequently asked questions. For those needing energy code checklists and also perhaps building energy certificates, those can be found under our checklists area. And then we also have several energy code smart tips for a lot of different aspects. One of our more popular ones seems to be on domestic hot water recirculation and circulation systems, the controls and the energy code requirements therein. So it's a good place to look. And again, we do have these linked off of our website. Presently, our codes will likely point to the 2018 International Energy Conservation Code. They do have the 2021 available, as well as the City of Chicago's. So that is a nice thing is the International Code Council does make all of their codes available free to view on their website. And so if you do have, if you are needing to look through something, and the search function is fairly robust on that. So you can go to the chapter 4 where most of the requirements are and do a search function and jump to where you're trying to get to fairly quickly. So it is fairly nice that they do make that available. So a couple of things we do want to touch on as we're coming up to the amendments for the state of Illinois. So these are anticipated in the state of Illinois and have already been adopted as part of the Chicago Energy Transformation Code. First of which is fenestration orientation requirements. So if you have projects that have a lot of glazing that are facing east and west, or where the majority faces east and west versus north and south, then you may be subject to these fenestration requirements where, depending on how much of a greater percentage is leaning east-west versus north-south, that you will have to increase solar heat gain or improve the solar heat gain coefficient and the U factor for the windows as well. So that is coming up. Lighting for plant growth. So for those that may be working on projects where they are greenhouse or other grow facilities, that is some improved requirements for that coming up. Now, this does not include those facilities that are subject to the Cannabis Regulation and Tax Act in the state of Illinois, as those have their own requirements built into that act as well, and so would not be subject to this. Also looking for some grid integrated controls. This doesn't require that the controls be connected and enabled, only that the equipment is able to receive these signals in the future. So it has the capability to receive it. It doesn't necessarily have to be connected. So this is for HVAC and domestic hot water heating. And as was mentioned earlier about looking for higher performance buildings, is they're adding the FIAS alternative compliance option. So if your project is going to be certified under the Passive House Institute standard, then you don't have to do anything beyond that to show energy code compliance. Due to this being such a high standard, it's been recognized that any building that meets the FIAS certification is going to be a high performance building that will far exceed the requirements of the minimum code for that, as well as the stretch code. So that's a nice way. And FIAS is available for both residential and commercial projects out there. So before I dive too far into this, I do want to learn a little bit more about everyone on the call. And so have a few polls today. So first, we want to know what section of the code do you struggle the most with? Understanding the different compliance methods, the building envelope, building mechanical systems, domestic hot water systems, power and lighting systems, or other. If you do mark other, go ahead and tell us in the chat what that is. And the second question, how comfortable do you feel with the provisions of the IECC? Do you know them well? You're generally familiar with them, could use a refresher, or what's the IECC? Have had a couple of questions come in, I see. Yes, the presentation deck. I will check to see that we can at least provide the link to that rather than necessarily attaching it. The files do generally get some sizable, so wouldn't necessarily want to push that through an email. But we'll try to at least get you the link for that as part of the certificate email. And public schools in the state of Illinois are under their own energy or their own building codes. So they are not subject directly to the state of Illinois' energy conservation code. As I believe right now, they are presently using the 2015 International Energy Conservation Code unamended. So as written for their code, whereas the Illinois Energy Conservation Code is using the 2018 version along with additional amendments beyond that. So I think we covered this as far as the base code for adoption that is slated to be adopted yet this summer. We'll continue to keep our website up to date as far as that timeline as when that becomes a little bit more available. And I believe I would anticipate that'll also be published in our news. An announcement will be published in our newsletter as well once that date is finalized. As a good point that people have brought up, that some of the regional jurisdictions may have project requirements where they have gone ahead and adopted a more recent version than the state minimum of the 2015. CPS, question about CPS. Do they use the same standard as the rest of Illinois public schools? I believe under state law they do. However, again, CPS may have gone ahead and adopted the Chicago Energy Transformation Code since they're in that jurisdiction. So that may, if you do have a specific question, make sure you check with either the local code official, or for schools, that would typically be the regional superintendent that is the authority having jurisdiction for that. So, all right, with that, let's see what we've got here. So looks like a lot of people struggle understanding some of the different compliance methods. We'll try to, not sure if we're going to touch too much on that today, but that's definitely good information that we will look to. If we don't really cover that today, we'll look to incorporate that into perhaps some of our future presentations here as part of the B for architects. So yeah, a lot of compliance methods. Then we've got some building envelope, mechanical, and lighting. So we're definitely going to touch on those three today. So as far as how comfortable people are, okay. The majority are generally familiar with IECC, with several people, we could use a refresher, which I presume that's why you're here today, and a few people that feel that they know them very well. So good to kind of have a baseline as far as where we're starting from. And with that, I'm going to turn it over to Robert to touch on some of our definitions and getting into that side of things.
All right, thank you, Ryan. As Ryan just said, I'm going to cover a couple changes and updates within some commercial definitions real quick before we get into the commercial envelope portion. So first, there have been some updated or new definitions for equipment buildings, computer rooms, and data centers. The most important thing to keep in mind with these definitions is that the key is to identify what equipment is being used and what electrical load that equipment has or needs. That is the primary difference between these definitions. And there's a little bit more involved with the equipment building definition that we will get into here in a little bit. This slide is not necessarily a definition change, but it does somewhat fit into the admin category. There are 6 counties within Illinois that have been moved from Climate Zone 4A to Climate Zone 5A. These 6 counties are Calhoun, Clark, Coles, Cumberland, Greene, and Jersey. So just keep in mind, if you are in those areas, you are now in a warmer climate zone. So you are now in 4A rather than 5A. Okay, so we will now move into the envelope requirements here. Before we cover into the requirements, let's talk a little bit about exemptions, possible exemptions to the code. So buildings that are typically exempt from normal building codes may, in this area that, or in our state, that often applies to agricultural buildings, but this depends on the local authority. Some counties don't permit ag buildings at all, which would mean that they are exempt from the energy code requirements. Some counties just don't happen to charge for the permit, which would mean that an exemption would be conditional. For buildings that do not contain conditioned spaces, such as storage facilities or potentially sports viewing stands or press stands, those spaces are not required to follow the energy code. However, if those spaces are ever updated to have conditioning, they will need to be brought up to the most recent code requirements at that time. Buildings without comfort conditioning, those buildings are usually considered without comfort conditioning if they have less than 100 amps of electrical service. If a building does not have comfort conditioning but does have a higher load than 100 amps, code official, local code official will have to give you a determination on whether or not an exemption applies. Listed historic buildings on the National Register, Illinois Register, or designated by another authorized personnel as historically significant are exempt from the energy code requirements. And then lastly, buildings that are specified within the IECC section C501.6, historic buildings. These would be buildings that are not on a historic registry or listed, but have some reasons as to why energy code requirements would threaten, degrade, or destroy the historic form or fabric of that building. For this exemption to apply, a report with specific reasoning must be provided to the code official. A new requirement, as Ryan mentioned earlier, these are available on our website, which I'll cover that in a minute, but commercial buildings must now have a commercial thermal envelope certificate. This must be posted in an approved location, which is often the mechanical room of the building. On this certificate must be recorded R values of insulation for roofs, walls, foundations and slabs, basement walls, crawl space walls, floors, and ducts outside of conditioned space, as well as the U factors and solar heat gain coefficients of fenestration, and the results of building envelope air leakage testing, which we will discuss that a little bit further on. This certificate is pretty similar to the requirements for the residential energy certificate, although the requirements between those are slightly different, as this certificate has a few more options in terms of envelopes and does not have duct testing, as that is not required within commercial buildings. As I mentioned, as Ryan mentioned, the certificates, both commercial and residential, are available free to use on our website. So if you like the look of our certificates, go to our website, take a look at them, download them, and use them in your projects. We find these certificates are very important in just recording project information. As buildings continue their lifespan, it's really nice to have that information recorded somewhere in case repairs or changes ever need to be made. So that's one reason why this is a very important requirement. So next, greenhouses. This is a new section underneath low energy buildings within the 2021 code. The opaque portions of a greenhouse must comply with the envelope components as insulation and air sealing components as they were any other commercial building. Internal partitions between the greenhouse and any other conditioned space must also comply with the insulation and air sealing requirements, as well as any fenestration solar heat gain coefficient requirements. The intention there with that second point is to thermally isolate the greenhouse from any adjoining adjacent spaces. And then lastly, fenestration must be in compliance with table C 402.1.1.1, which we have shown there. That table designates both skylights, which would be the upward facing glazing components, as well as vertical fenestration. Equipment buildings, as I said earlier, come back to this definition a little bit here. The only real change between 2018 and 2021 was the square footage of equipment buildings has been increased. In the 2018 code, the maximum square footage was 500 square feet. Now it is 1,200 square feet. Equipment buildings still have to be housing electrical equipment greater than 7 watts per square foot, not intended for human occupancy, have heating systems with a capacity less than 17,000 BTUs per hour with a set point restricted to 50 degrees or less, and the average wall and roof U factors must be less than 0.2 in our climate zones. This is a excerpt from table C402.1.3. We've pulled out the walls and roofs requirements for climate zones 4 and 5. We've highlighted the boxes there where changes have been made, improvements are made there. So the black text shows the 2021 requirement values and the white text shows the original 2018 requirement values. This excerpt from the same table shows floors within climate zones 4 and 5. The same highlighting there of the boxes or requirements that have been updated and changed. One note here is that heated slab on grade construction, insulation is permitted to stop at the bottom of the slab edge and heated slab on grade construction. And our interpretation of that is that as best practice, heated slabs should always be wrapped, both bottom and slab edges, in insulation in order to isolate that slab from the surrounding structure. Now looking at the U table, so table C402.1.4, same highlighting of the updated requirements. These are in line with the updated requirements of the R value table. The U value table obviously gives you a little bit more flexibility in what type of assemblies you're using without going into another compliance path beyond the prescriptive compliance path. So if you'd like a little bit more flexibility in what your wall assemblies or other assemblies look like, look to the U factor table in order to find your insulation requirements. And lastly, we have the excerpt here from the U value table showing doors and floors within climate zones 4 and 5. One note, the 2021 IECC has corrected the heated slab F factor listings to match ASHRAE 90.1. It's not necessarily an improvement, but it is bringing the two codes closer in line. Another note is that non-swinging doors that used to be housed in the 2018 R value table have now been moved to the U factor table in the 2021 IECC, and the requirements have been relaxed just a little bit. Oops, sorry. Staying with doors here for a little bit. This section has been clarified and refined a little bit to bring in a couple different door types. So opaque doors, non-swinging or swinging with less than 50% glazing shall comply with table C402.1.4 that we just looked at. and those doors must be considered as part of the gross area of the above grade walls. Opaque non-swinging doors, so overhead doors, horizontally hinged doors are broken up into horizontally hinged doors with fenestration and without, and those have their own requirements there listed in the table. So horizontally hinged doors with the given amounts of fenestration must have a U factor of less than 0.44 in our climate zones. And then doors without fenestrations, see the table for those requirements. Tapered roof insulation. This section has been slightly modified in the 2021 code. The average R value can be used for tapered deck insulation. The minimum thickness shall be 1 inch. A minimum of 2 staggered layers are required except at gutter edges, drains, and scuppers. This here is one of the main differences between the 2018 and 21 code. The 2018 code used phrases such as at roof drains rather than listing the specific locations. There is also a separate section, C 402.1.4.1.1, that lists comparable requirements for U factor compliance with roof tapered insulation. For perimeter insulation, this is no real change here, but just a minor clarification in the 2021 code that clarifies when the slab on grade is greater than 24 inches below the finished exterior grade, perimeter insulation is not required. As mentioned before, if you have a heated slab, the requirements will be different. The minimum skylight requirements have been updated with a new exception for spaces that are designed as storm shelters in accordance with IECC 500. So spaces that are designed as such do not need to meet the minimum skylight requirements. For fenestration, max U factor, and solar heat gain coefficients, the values in the table have been slightly updated. There is a little bit of improvement within the U factors, but the biggest change here is that you no longer determine solar heat gain coefficient by orientation of the fenestration. Solar heat gain coefficient requirements are now determined by whether or not that fenestration is operable. So if it is fixed or operable, you have different solar heat gain coefficients there, as well as the projection factor, which has not necessarily changed. As Ryan mentioned earlier, there is a proposed Illinois amendment that would essentially impose a little bit of a penalty for buildings that have primarily east or west fenestration or large amounts of east to west fenestration. And this is in order to compensate for the higher heat gains that those orientations see if you have significant amounts of glazing there. So what you would have to do is follow the given formula to see what your adjusted solar heat gain coefficient might need to be depending on the ratio of east to west glazing compared to the rest of your building. As I said earlier, minimum skylight requirements have a new exception for storm shelters. Another change within this section for the 2021 code is the addition of information about tubular skylight systems. These systems are becoming a little bit more popular, and so the code language has been updated in order to account the differences between tubular solar tube type systems and traditional box skylights. The requirements, though, are visible transmittance of not less than 0.4 or annual visible transmittance of not less than 0.26. The effective aperture has to be 1% using visible transmittance for standard skylights or 0.66% for tubular skylight systems. Air barrier requirements. This is not necessarily a change in the 2021 code, but we like to take this moment here to input a little bit of building science while we can. So the important point here is that air barrier materials must be installed inside, outside, or as part of the envelope assembly. There is no and there. They should either be there's only one continuous air barrier within the wall assemblies. You can have multiple air barrier materials as long as there is only one continuous air barrier. And the issue here is that air barrier materials are often also vapor retarding materials. And if you have two vapor retarding materials within one assembly, you have the potential to trap moisture within that assembly, which can lead to degradation and mold issues. So one way to think about this might be a masonry wall that has an interior skim coat of spray foam to provide a continuous interior air barrier. Interior wall framing with drywall on the interior side of that wall could also stand as an air barrier, but that wall would most likely have punctures by electrical boxes and service openings. And so that component of drywall and framing is not acting as the continuous air barrier within that assembly, and you would not want it to, because then you could potentially trap moisture within that framed assembly. So just keep in mind that the idea here is that we want our assemblies to be able to dry either to the exterior or to the interior. We don't want to be trapping moisture within our assemblies. And then there are sections listed there for requirements on air leakage through fenestration, as well as air leakage through purposeful openings. Next requirement, this is probably one of the biggest changes upcoming in the 2021 code. Essentially, all commercial buildings in Illinois must now be pressure tested to verify air barrier compliance. We'll get into the specifics of the different testing types for dwelling and sleeping units and other commercial buildings here in a minute. There are no exceptions for our climate zones of 4A and 5A. So again, all commercial buildings within Illinois must be pressure tested under the 2021 IECC. As I mentioned, there are some exceptions, but they do not apply for our climate zones. So if you're in any of the climate zones listed above, the performance verification listed within this section may apply and is mandatory. But for buildings within Illinois, this exception will not apply. All commercial buildings will still need to be tested. But if you do work outside of the state, this exception may apply to that project. So dwelling and sleeping unit enclosure testing. The measured air leakage shall not exceed 0.3 CFM per square foot of testing unit enclosure area at 0.2 inch water gauge or 50 pascals. If you are testing multiple dwelling units within a single thermal envelope, you test each individually, and then the building leakage rate is the unit envelope area weighted average of all of those leakage rates. If you have units tested separately with an unguarded blower door test, it must follow the procedures below. So if you have a building with fewer than 8 units, you must test all of them. If you have a building with 8 or more units, test the greater of 7 units or 20%. And depending on the layout of that building, you need to take an appropriate samples selection through there. So you would have to take 1 unit at the top floor, 1 unit at the ground floor, and 1 unit with the largest enclosure area. Each unit not in compliance requires 2 additional units to be tested. This dwelling and sleeping unit enclosure, so this is for dwellings and sleeping units within commercial buildings. The requirements for residential dwelling units are different, and we will touch on those a little bit later. The main difference is pressure difference, and then also how the leakage rate is calculated. For residential buildings, it's air changes rather than enclosure area leakage. So for all other commercial buildings, not dwelling units or sleeping units within commercial buildings, but just all other commercial buildings, the measured air leakage is not to exceed 0.4 CFM per square foot of thermal envelope area at 0.3 inch water gauge, so 75 pascals, a little bit of a different pressure testing there. And for larger buildings, you may be asking, how might you test a large building? There's a sampling procedure for that. So the area weighted average of the building can't exceed the whole building's air leakage limit. And the sampling procedure for that would be to test the entire area, envelope area directly under a roof. So any area that is directly under a roof must be tested. Any area that has a building entrance, exposed floor, loading dock, or is below grade must be tested. And then 25% or more of the representative sample of the remaining building must be tested. So if you have a large tower building, you test the top floor, you test the bottom floor, any below ground floors, and then 25% of the rest of the building. This bottom point here is probably pretty important for a lot of projects. If total leakage is between 0.4 CFM per square foot and 0.6 CFM per square foot, you are allowed to complete diagnostic testing and non-destructive remediation without requiring any additional testing. So this is essentially saying that you've gotten pretty close to the requirement. We don't necessarily need you to do any destructive remediation or do any significant work. Let's try to do what type of sealing we can without a significant amount of new work, and then not require you to test again, because you're within that fine margin of error there. If you are outside of this range, there will be further remediation that is required, but if you're within this fine range, you can do some simple diagnostic testing and non-destructive remediation and not require additional testing. A report of the corrective actions must be submitted along to the code official. Another new requirement in the 2021 IECC is operable openings interlock controls for HVAC systems. So any conditioned space with a door that is greater than 40 square feet opening to the exterior needs to be provided with controls that change the HVAC settings when the door is opened. Those settings the controls need to be able to disable the heating or lower the set point to 55 degrees or lower, or disable the cooling or raise the set point to 90 within 10 minutes of the door opening. This requirement is aimed at the popularity of overhead doors and large openings within public spaces these days, which we can all agree that these spaces are pretty nice to be in. The thing that we want to limit is HVAC systems within the connected interior spaces running at full bore, trying to condition the exterior air. So the point of this requirement is so that when those doors are open, the HVAC system is aware that there's a greater connection to the outside and the set points change so that we don't waste energy trying to condition outdoor air or space. Additional efficiency requirements. So there has been a bit of a change between 2018 and 2021 for this. Formerly, it was projects must choose one measure and implement that one measure. Now, under the 2021 code, you must collect 10 points from a table of measures and points that the 10 points equals roughly 2.5% energy savings. The points value tables are based on occupancy groups as they were before. And then as Ryan mentioned earlier, there are some proposed Illinois amendments for grid integrated HVAC controls and grid integrated water heating controls. And those proposed amendments, essentially that if a project were to select this additional efficiency measure, the thermostatic controls within the building would need to be capable of automatically increasing the zone cooling set point by a minimum of 4 degrees, automatically decreasing zone heating by a minimum of 4, automatically decreasing zone cooling by a minimum of 2. They also must allow for ramp up and ramp down logic to prevent peak demand from exceeding that expected without the demand response implementation. And as Ryan said earlier, this is really that the buildings need to be capable of this. It doesn't necessarily need to be implemented and up and running as the building is put into use, but the building needs to be set up so that this can be implemented in the future. That is how you would get credits from this additional efficiency measure. And here we have taken an excerpt from the additional efficiency measure table in section C406. So we're showing the measures and points available in climate zones 4 and 5 for some of the different occupancy groups here. 1 point to note here in this table is that some of these measures provide you 10 points or more, others do not. So depending on which measures are selected, a project may only need to choose one measure or maybe 2, depending on which measures are selected. So even though there was a change from 2018 to 2021, depending on which measure you pick, you may still only need to implement one of these additional efficiency measures. And then now I believe we have a second poll question. So second poll question here is, what building types in Illinois require envelope testing? Group R and I, other than group R and I, or all new buildings? And question 2 is, how soon does the operable interlock on an overhead door need to trigger a change in HVAC operation? Would it be immediately, within 10 minutes, within 20 minutes, within 30 minutes, or within an hour?
And see, we've had a few questions come in. First, regarding the exemption language for 100 amps, that 100 amps electrical service, and how that's written in the Illinois Energy Conservation Code is if the electrical service is 100 amps or more, then the building is presumed to be conditioned. And you would have to make the judgment otherwise, regardless of if the conditioning equipment is installed or not as part of the project. It is just presumed to be conditioned. So if you have 100 amps or more electrical service to a building, and you want to use that exception and say, no, it's not used for comfort conditioning, then you have to make that case to the code official for them to either say, yes, that's, yes, this is not for comfort conditioning, or, no, it could be. So you have to follow that. So questions regarding penalties for non-compliance with the Illinois Energy Conservation Code. The penalties as part of a project, you are certifying as a design professional that this is compliant. And so failure to comply potentially could be risk of your license to practice. But the other side of that could be if a building does not comply, you might be potentially held liable by the building owner for the excessive utility consumption for that. So not something we necessarily want to get into, but just being aware that that is out there. It's part of the reason why we try to encourage people to understand what the requirements are. Typically we find, and we won't touch on this today, but existing buildings, we get a lot of questions on. So do check out our frequently asked questions on that. But a lot of the fear of compliance and people not wanting to comply has more to do with misunderstanding how the code is actually written than anything else. So with that, I do see we have a few others, but let's go ahead and close our poll and
so looking at the results here, it looks like almost everybody got the first question right. It would be all new commercial buildings that need to be pressure tested. And the second question, it looks like mostly everybody got that one right as well, that those the operable opening interlock controls need to be activated within 10 minutes of that door opening. All right. And now I will hand it over to Ryan for the commercial HVAC requirements.
Okay. All right. So on the commercial HVAC, I see we do have some other questions on the envelope, and we will come back to the questions a little bit later. But I do want to make sure that we are respectful of everyone's time, and we definitely finish on time. We will plan to stay on and continue to answer questions if we at the end as well. So as far as commercial HVAC systems, fault detection, this is a new one. Previously, we had fault detection for economizers. New to the 2021 IECC is fault detection being expanded to encompass more systems. So this is for larger buildings, so 100,000 square foot and larger building. Then you need the whole HVAC system has to have fault diagnostics and detection. So this covers some of the aspects. Have to have permanently installed sensors monitoring it, so it can't be just temporary from the commissioning process. Has to be sampling at least every 15 minutes, identifying and reporting faults, being able to notify the authorized personnel for that, and prioritize the recommended repairs. So it can't just be a static list of alarms. It has to be able to prioritize and say this one is being more impactful than that one, fix this one first, then working through that, and also being able to transmit those recommendations to remote personnel. Understanding oftentimes buildings may not necessarily have building control experts in-house, but may have that farmed out. And so being able to not only communicate that to the building maintenance personnel, but potentially people such as your HVAC controls contractor, and letting them know. This does exempt R1 and R2 occupancies. So again, we can have commercial buildings with residential occupancies in them. So a large high-rise apartment building would not necessarily trigger this, but commercial we would. So here's some things that could look like. So understanding that, hey, we've got some the actual damper position versus our expected. And so it's tracking how many anomalies. And so this is oftentimes how this may be dealt with, is it's tracking the anomalies and saying, hey, this system over here has more anomalies than that. So fix this one first, and trying to provide that. And as we see here in this chart, it's illustrating the dramatic impact that can have from fixing equipment. Well, for the 2021 IECC, they pulled out for data centers, and Robert talked about earlier what constitutes a data center in the definitions. So data centers are going to be using ASHRAE 90.4 for their equipment. However, IECC does have a couple of tables that they, when you go to use ASHRAE 90.4, that they would say use this table in lieu of the one that is published in the standard. So they've also added this to the HVAC equipment performance standards. So you'll see that those standards, those tables of minimum efficiency requirements continue to grow over time, but they're the same as the federal minimum of appliance efficiency standards. So don't get too hung up on that. As far as 2021 IECC, they've added VRF systems as those have become more popular, and a few other equipments, along with, again, pulling out computer room air conditioners and condensing, and some water source heat pumps. So a little bit of clarification on some of those. For those of you who may not be aware, beginning January 1st of this year, the standards SEER and HSPF, or heating season performance factors, have been updated. Their standards have been updated. And so we've now moved from SEER to SEER 2 and HSPF to HSPF 2. So being aware that that performance changed. So this is likely to mean that they're going to, the ratings that you may see may be a little bit lower under the SEER 2 than you saw under the SEER rating. And that's partially because the testing criteria has been moved to a more rigorous testing standard. So you'll see that those values do vary a little bit, but not dramatically. So it's not like a piece of equipment will have moved from, you know, an 18 SEER to a 14 SEER 2 or something like that. It'll be just a little bit different. So, but that's good to be aware of as equipment's being delivered to the job site. If someone has some old attic stock, just double checking that has been, that they're not selling you the old equipment. So, supplemental heat prevention, this they've gotten a little bit more specific on. Previously, it just said, hey, when the heat pump compressor cannot meet the heating load, then you can use the supplemental heat. In the 2021 version, they have improved the language of this and saying, hey, here are the 4 conditions that may allow you to trigger that. Vapor compression, not providing adequate heat. That would be the traditional definition of compressor cannot meet the heating load, but now also recognizing, hey, the heat pump may go into defrost mode, which may require supplemental heat during that period. I might malfunction the compressor, or my thermostat has a malfunction. So providing a little bit more clarity on that. Also now for heat pump loops, medium and large heat pump systems, having 2-position automatic valves interlocking with the compressor such that we're not pumping water through a compressor that's not trying to move heat. So we're not diluting the mains of the loop. And so for medium to large systems, you know, when the compressor is off, the valve closes and we don't flow any water through that system. Automatic start and stop. This may also be known as optimum start and stop. Previously, it was just optimum start is what people focused on. New to the 2021, we now have optimum stop. So this is more of a coasting towards the end of the day. So you still would have your setback for overnight, but for the last, the last period of time, the last, 30 minutes or an hour or something like that, the building can kind of coast into the end of the day. So this is calling out that we need to set it back. That setback for the coast would be 2 degrees before our scheduled unoccupancy or minimal occupancy, allowing the building to drift a little bit as people are kind of filing out at the end of the day. For those who do use VRF systems with dedicated outdoor air systems, they've added an exception for economizers, understanding that because VRF with these energy recoveries and dedicated outdoor air systems are fairly high efficiency, the gains from adding economizers are not that dramatic. So they've added an exception in there to say, because you've selected a much more efficient HVAC system, we're going to go ahead and allow you to not have to have economizers for that. We still do need to have economizer fault detection for those buildings that do have economizers. So this earlier I had mentioned about a building automation system fault detection. So system-wide fault detection that triggers at 100,000 square feet building or larger. Economizer fault detection still applies even for smaller buildings. Calling out that, we're monitoring supply, return, and outside air temperatures, status report and alerting, hey, I have a fault, someone please come fix me, because economizers can be rather energy intense if they fail to operate properly. So we do want to make sure that people understand if they have a fault or are not working properly, that they can get fixed. An extreme example, I was working on a library that it was probably 95 degrees outside. So it was a hot day. One of the temperature sensors humidity sensor had faulted out. And so the building had gone into economizer mode. With that, the building was using up 450 tons of cooling. Once identified the issue and fixed the sensor and turned off the economizer, the building dropped from the 450 tons of cooling to 150 tons of cooling. And again, this was a 95 degree day outside. So, 300 tons of cooling is very expensive just due to one sensor. So that's why we want to make sure that people know when that has gone awry. Demand controlled ventilation, this has been reduced as far as the allowance for this. It used to be 25 people per 1,000 square foot. Now it's 15 people per 1,000 square foot for this. So most any spaces, a lot of spaces that are 500 square foot or bigger, you're going to need to be doing demand controlled ventilation for these. Along with that, I did update some of the exceptions for this, particularly this last one. So if you do work with correctional facilities or education or some of these specialty locations, that economizers or that demand controlled ventilation would not be required. And a predominant reason for this is either occupancy, such as correctional cells. These are occupied 24 hours a day, 7 days a week. And these others, we are needing to ventilate for reasons other than human occupancy. So that's a primary reason why these were changed. Also have parking garage ventilation. It used to be 22,500 CFM or less without mechanical heating. 2021 updated this to 8,000 CFM or less. So that's a dramatic change for this. As far as dwelling unit versus non-dwelling unit, so this is for energy recovery requirements. So dwelling unit has a the dwelling units do have a different requirement than non-dwelling units here. Calling out the dwelling units, we need a higher energy recovery, again, because those are going to be occupied fairly much more routinely. Again, we typically see more round-the-clock occupancy in dwelling units. So airflow requirements, this is not a change, but we do want to bring up the note that if you do have fans and airflow that is that you are bringing in outside air more than 8,000 hours a year, these thresholds are very low for energy recovery. So most any systems that are operating year round, you're pretty much going to be required to do energy recovery on it. So guest room, this for those of you who have seen previously in occupant sensors for lighting that move from 30 minutes down to 20 minutes. Similar thing has happened in guest room HVAC controls. Again, moving down to 20 minutes of on occupancy for that. So this is for buildings with at least 50 or with more than 50 guest rooms in them for that. The fan efficiency previously used the fan efficiency grade, now moving to the fan efficiency index. And what that kind of takes into account is the fan energy index is kind of looking at the overall system and have you optimized the overall system. So that's why we're requiring that fan energy index of 1.0 or higher. You know, are we really optimizing that? Whereas before, under the fan efficiency grade was just what's the efficiency of this particular fan to move air, and it didn't really take into account the entire system. It just looked at the fan itself. So also have our low capacity ventilation fans. This there's a little bit of a rearranging on this, so just being aware of some of this. This is more just rearranging where some of those requirements are. So with that, let's do another poll. We'll answer a few questions here too. Yep. When is equipment sizing required to be performed? Is it only during new construction, only if you're changing the sizing, or just anytime the equipment is installed or replaced, size it correctly? Second question, for a building of 50,000 square foot, so we're under 100, which type of fault detection is required? No fault detection, economizer fault detection, or the building automation system fault detection. Let's see here, a couple of questions here. The 10 kW for the water source heat pumps, the 10 kW is based on the heat pump capacity. So you would add all the heat pumps together, and as their heating capacity, 10 kW is how that works. Fault detection for warehouses. So you've got 200,000 square foot of heating only and 5,000 square foot of fully conditioned office. Again, you'll have been over that threshold, so they will require more monitoring for that. But the specific requirements when you're looking at a warehouse with just infrared heating, what you monitor may be much less than you would on a full VAV system. Let's see here. Question about permitting and time for permitting. Permit is applied for under the 2018, but a permit is not issued. Would it have to comply with the 2021 if it gets adopted prior to issuance? And that's where the in almost every jurisdiction we have encountered, they look at what is the permit application date, not what is the permit issuance date. So because part of that is as part of the permit application, you are certifying that it meets all applicable codes at the time of application. So if a code changes after you've applied for your permit, that would not necessarily be seen as your responsibility. So again, that's where they look at the application date, not the permit issuance date on that. So, all right, let's take a look here. Equipment sizing needs to be performed. Yes, anytime the equipment is installed or replaced, understanding that because things change over time, uses change over time, loads change over time, anytime the equipment is replaced. So obviously the first time it's installed, and then anytime you replace it, do your load calc. And for a building, 50,000 square foot, yep, most everyone picked up. Economizer fault detection is what would be required for that. So with that, I'm going to turn it over to Robert to talk about commercial lighting.
All right, thank you, Ryan. So commercial lighting, the first requirement we're going to talk about here is a new requirement for dwelling units, and this is dwelling units located within commercial buildings. Dwelling units within commercial buildings must have not less than 90% of the permanently installed fixtures containing only high efficacy lamps. This is different from the residential building provision, which we will cover later on. The definition for high efficacy lamps is lamps that are not less than 65 lumens per watt. Oops. One too far. So occupant sensing controls. So the list of occupant sensing controls here includes classrooms, conference rooms, copy print rooms, lounges, break rooms, enclosed offices, open plan office areas, restrooms, storage rooms, locker rooms, other spaces 300 square foot or less enclosed by floor to ceiling partitions or warehouse storage areas. In the 2021 code, they have added corridors to this list. So corridors now also need occupant sensing controls. There are some specific requirements for corridors, and we will touch on that here in just a little bit. First, we will touch on warehouse occupant sensor controls. So occupant sensor controls are required in warehouses, and those controls must reduce the lighting power by at least 50% when the space is unoccupied within 20 minutes of vacancy being detected. These controls must cover the aisleways and open areas, and they must control each aisleway independently and shall not control beyond that aisleway. Lights not turned off by occupancy sensors within warehouses shall be turned off by time switch controls, complying with section C 405.2.2.1. And also manual controls within warehouses must also be provided. So even if there are occupancy sensors or time switch controls, you must also provide manual controls. Next, we will talk about occupant sensor controls within open plan office areas. So this is within open plan office areas that are larger than 300 square feet. Within those spaces, individual lighting zones are limited to 600 square feet. And controls within those zones must reduce lighting power by at least 80% in a reasonably uniform pattern within 20 minutes after no occupancy is detected. The controls must turn off the general lights in all zones within 20 minutes of occupants leaving, and controls can actually turn off all general lights or uniformly reduce lighting power to an unoccupied set point of not more than 20% after 20 minutes. So that 0.3 there, the controls can either turn the lights off or reduce them to not more than 20% lighting power. And then lastly, daylight responsive controls may activate fixtures only if occupants are present. We don't want daylight responsive controls activating lighting when there's no one in the space to need the lighting. Okay, so as I mentioned earlier, corridors have now been added to the list of spaces that require occupant sensor controls. Controls in corridors must reduce lighting power by at least 50% in a reasonably uniform pattern within 20 minutes after no occupancy. There is an exception for corridors that may be especially dark. We don't want to make any corridors that are already dark more dangerous or have any sort of hazards within them. So if there's a corridor that has a measured lighting power measured at 2 foot candles on the floor at the darkest point with all lights on, that corridor does not need occupant sensing controls. Occupant sensor control function within other areas. This has not necessarily changed within the 2021 code. These sections have just kind of been reorganized a little bit. So the occupant sensor controls in other areas need to turn automatically off within 20 minutes of occupants leaving. They can be either manual on or auto on if not more than 50% power. And the controls shall incorporate manual control to allow occupants to turn the lights off. This is essentially giving occupants some agency over their space, some ability to control the lights themselves and not having all lighting control done by automatic controls. There is an exception to requiring manual controls within a space where that may endanger occupant safety or security. So in a space such as that, full auto on without manual control is permitted. Light reduction controls. So these requirements are for spaces that do not have occupant sensing controls. Manual controls must uniformly reduce lighting by at least 50%. And must include an intermediate step between 70% and 30% power, or with continuous dimming control, a minimum of 20% or less. And there are multiple strategies of controls that you control strategies here. You control all lamps or luminaries. You can switch alternate rows or luminaries. You can switch inner and outer lamps, or you can switch each lamp and luminary individually. There are exceptions listed here. For spaces with daylight responsive controls or special application controls, and also manually controlled spaces with one luminary rated less than 60 watts, spaces with less than 0.4 watts per square foot, or corridors, lobbies, electrical and mechanical rooms. The intermediate step within these requirements here is a new requirement that's also bringing the IECC in line with ASHRAE 90.1. So another instance where the two energy codes are being brought in closer alignment. And then these exceptions listed here are generally for spaces that don't have configurations where uniform dimming or these lighting step controls are not applicable, or where they are not cost effective. So beginning to talk about daylight responsive controls. Before we talk about daylight responsive controls, we like to bring up that there is an exception for the requirement for daylight responsive controls. Daylight responsive controls are great in limiting lighting when there is enough sunlight available, but daylight responsive controls can also add complexity to a project. So we like to encourage designers to consider this exception whenever you are designing spaces that may apply. So to apply for this exception, the connected lighting power must be less than the adjusted lighting power budget. And you get the adjusted lighting power budget by following the given formula there. If you follow that formula and you are below the threshold, you do not need daylight controls within that space. To look at this in a little bit more detail here, we'll take a look at a quick example of what this might look like. So the example one there is an office building that is a 200,000 square foot building with 100,000 square feet of daylight zones. So what is the total lighting power budget? Well, we would go to table C405.3.2 to find the lighting power density for offices, which is 0.64 watts per square foot. If you take that 0.64 watts per square foot times the entire square footage of the building, you get a lighting power allowance of 128,000 watts. And now to get to the adjusted lighting power allowance from that, we would follow the formula on the previous slide. And from that formula, we find that we need about 20% less lighting power within this space in order to apply for the exception for daylight controls. Now, if we look at the second example here, it's another office space, same size building, but less square footage within daylight zones. And since this equation is based on area weighting, the target reduction is also smaller. So in the second example here, rather than a 20% reduction, we need a 10% reduction in order to apply for the exception for daylight controls. Now, one important thing to keep in mind with this exception is that if your project is pursuing the reduced lighting power additional efficiency measure in section C406, that needs to be applied before this equation is put in place. So you would need to take your lighting power density of 0.64 above. That lighting power density would need to be reduced by 10%, and then you would need to go through the adjusted lighting power allowance calculation to see how much more you would need to reduce the lighting power in order to both comply with the reduced lighting power additional efficiency measure and be exempt from requiring daylight controls. So just keep in mind there that if you're going for that additional efficiency measure, this equation is not as straightforward as it looks on this screen. Okay, so daylight controls in general in other spaces that are not exempt. Where are they required? They're required in spaces that have greater than 150 watts of general lighting in the primary side lit zone, or spaces that have greater than 300 watts of general lighting within the primary and secondary side lit zones. This is a new item within the 2021 IECC. They have included in the 2018, there were only primary side lit zones. Now there are primary and secondary side lit zones, which we will touch on here in a bit. So that is a new point here in this section. And then the third one there, spaces that have greater than 150 watts of general lighting within a top lit zone. So there are some listed exceptions for healthcare facilities where patient care is directly provided, where we don't want lights going off at times that may cause issues. There are also a list of lighting for special application control that is exempt from these requirements, and then side lit zones on the first floor above grade and specific occupancy groups are also exempt from daylight control requirements. It's not wanting to go. There we go. Okay. Whoops, I skipped one. Okay, daylight control functions. So this list has been slightly expanded from the 2018 code. Daylight controls must control top lit and side lit zones separately. There is a 150 watt overlap allowed. The controls must control primary and secondary zones separately as well. The controls must be able to be calibrated within the space that they are controlling. The calibration mechanism must be readily accessible. The controls must be able to continuously dim down to at least 15%. Controls must be able to turn the lighting completely off. The controls cannot brighten lights beyond unoccupied set points set by occupant sensing controls. So again, daylight controls cannot turn the lights on if there is no one within the space. And then side lit zones of different cardinal directions must be controlled independently. So if you have side lit zones next to each other that are facing different cardinal directions, those two zones need to be controlled independently. There is an exception there that if there's less than 150 watts of lighting power in each zone, those two zones can be controlled together. And a quick note again on this one is that the 15% reduction target is no longer specific to certain spaces and applies to all daylight zones now. So side lit zones. As I stated earlier, the 2021 code has now included a definition for secondary side lit zones along with primary side lit zones. Side lit zones are determined by looking at the floor area adjacent to vertical fenestration. The area of the fenestration must be greater than or equal to 24 square feet, and the visible transmittance of that fenestration must be greater than or equal to 0.2. Within the code, they provide graphical representations of what the definition of side lit zones are, and those graphical representations are shown for you there. One note is that the 2021 code has reclassified rooftop monitors as being in side lit zones rather than top lit zones. The definitions of the zones are primarily unchanged beyond the addition of secondary side lit zones, and also projection factor is now included within these requirements. So if your side lit zone, if there's an overhang on the fenestration or on the rooftop monitor, you must take that projection factor into account within the 2021 IECC. Top lit zones, very similar. The floor area underneath a roof fenestration, there must not be buildings blocking direct sunlight from hitting the fenestration at peak solar angle. And then the visible transmittance times the area of the roof opening divided by the top lit zone area must be greater than or equal to 0.008. Again, I find these graphical representations in the code very helpful in determining side lit and top lit zones. I think the graphical representations really do a good job of explaining of what these zones actually are. Oops, skipped one again. And then atriums. Daylight zones have been established in atriums on the top floor of the atrium, but no intermediate floors as shown. So it's the top floor and the bottom floor, but none of the intermediate zones as shown in those two as shown in the graphical representations here. This is again another addition to the 2021 IECC that brings it in closer alignment with ASHRAE 90.1. So again, another instance of the two energy codes trying to align a little bit closer. Next, exterior lighting controls. So this section has some minor changes and reorganization from the 2018 version of the code. Decorative lighting is now facade and landscape lighting. There are a couple general exceptions for section C 405.2.7 exterior lighting controls. Those general exceptions are lighting for covered vehicle entrances and exits from buildings and parking structures where required for eye adaptation. So that lighting does not need to have exterior lighting controls. And then lighting controlled from within dwelling units also does not need to have exterior lighting controls, meeting the requirements listed within these sections. And we will dive into a couple of these sections here next. So exterior lighting controls under section C405.2.7, they must have daylight shutoff. Facade and landscape lighting must automatically shut off an hour or less after business closes and an hour or less before business opens. Lighting setback. For exterior lighting, required setback is to reduce exterior lighting by at least 50% by switching or dimming during one of the following times, from not later than midnight to not earlier than 6 a.m. Again, from up to 1 hour after business closes to up to 1 hour before opening. And then during any time where activity has not been detected for more than 15 minutes. Luminaries that are greater than 78 watts and 24 feet or less above the ground require occupant sensing controls. And then time switch controls are the same as interior time switch controls, where they are required to have seven different daily schedules. Also, they need to have the ability to have a holiday setback feature, and they need to have 10 hours of program backup capability for power outages. Parking garage lighting controls. So this is a new section within the 2021 code. Daylight responsive controls must be installed within 20 feet of perimeter wall openings to reduce lighting power by at least 50%. There are listed exceptions within the code for this requirement, depending on the depending on the architectural assemblies of the exterior walls. So if there's architectural screening, or depending on the opening sizes and locations, there are some exceptions that apply to the daylight responsive controls being required. Within the parking garage, so within the perimeter, not around the perimeter, but more in the interior spaces, occupant sensing is required to reduce the lighting power by at least 30% within 20 minutes of inactivity. This excludes zones provided with less than 1.5 foot candles of lighting on the floor at the darkest point with all lightings on. So again, similar to that corridor requirement, if the space is already pretty dark, we don't want to necessarily make it even darker and make it a dangerous or hazardous location. So there is an exception there for spaces that are already pretty dark. And again, eye adaptation zones are to be controlled separately. So eye adaptation zones at entrance and exits of parking garages. Those controls, the eye adaptation zones must have their own controls, which must reduce power by at least 50% from sunset to sunrise. Total connected interior lighting power. There's really only slight changes from the 2018 code here. So just a little bit of a review. So when you're performing total connected interior lighting power calculations, all of the above must be included. Lamp wattage labels for line voltage lamps, ballast transformer input wattages, LED driver input wattages, and then track lighting, either connected wattage, transformer wattage, or 8 watts per foot, whichever is greater. And then in order to get your interior lighting power allowance, there are 2 methods. These two methods have been updated some in the 2021 code and have been slightly rearranged, but there's no significant changes to the methods themselves. Those two methods are the building area method or the space by space method. Within the space by space method, there are additional allowances for certain special use lighting. That list of special use lighting is pretty long, but it includes things like special task lighting, that includes medical lighting, theater performance lighting, TV production lighting, advertising, lighting for plant growth as well. So there is a long list of special use lighting there with additional allowances. And then looking at an excerpt of table C405.3.2, looking at the lighting allowances for different spaces. So these are pretty general categories, as you can see, and then some are even broken down a little bit more. So we've got a couple different dining spaces types within there that have different allowances given. And as you can see, there's some of these allowances that have been made more stringent from the 2018 code, and then some of them have actually been relaxed from the 2018 code. Within the table, one of the uses that has the highest allowed lighting power allowances is hospitals, which have a lighting power allowance of 0.96. As mentioned before, though, hospitals would also have medical task lighting and other special use lighting that may not be included within these calculations. So as Ryan mentioned before at the beginning of the presentation, there is a proposed Illinois amendment to increase the stringency for lighting for plant growth. So all permanently installed luminaries shall have photon efficiency of not less than 1.7 micromoles per joule per ANSI and ASABE S640 for greenhouses, and 2.2 micromoles per joule for all other indoor growing spaces. And as Ryan mentioned, there are exceptions for a few different building types here. One of them is buildings with no more than 40 kilowatts of aggregate horticultural lighting, and then cannabis facilities subject to 410 Illinois CS. So Illinois state cannabis facilities that have their own lighting requirements there. Exterior lighting power allowance. So this section has really just been reorganized in the 2021 code. So the way that you would determine your exterior lighting power allowance is first to determine which zone you are in, these zones are determined based on population. So really in the state of Illinois, most locations will most likely be in zones 2 and 3. Zone 4 really only applies to Chicago in Illinois. That is the only location in downtown Chicago itself. Is the only place within the state of Illinois that would apply for zone 4. And that zone 4 is based on having an urban core area of at least 50,000. I believe that's a population number there, right? Okay, another new requirement within the 2021 code is automatic receptacle controls. This is another pretty big and potentially impactful requirement within commercial buildings. At least 50% of receptacles in all enclosed offices, conference rooms used for primary print and or copy functions, break rooms, classrooms, and individual workstations. And then at least 25% of branch circuit feeders installed for modular furniture that is not shown on construction documents. So those two instances there need to have automatic receptacle control, and the way that these automatic receptacles are controlled can be based on a few different things. It can be time of day basis, it can be occupant based, or it can even be control signal based. So it could even be that as people badge in and out of the building, their outlets within their office power on or off, depending on if they're leaving or coming. This requirement could be a big one and could be a hard one to sell to clients or customers. You don't necessarily want to have outlets turning things off uncontrollably, but that's not necessarily the way to think about this. This is more that these outlets are provided so that the building can turn things off that you might otherwise forget to turn off. So if you're in the habit of turning your computer off at the end of the day, or if you'd like to be in that habit, these automatic receptacle controlled outlets would be what would be used for that. So you would plug your electronic devices into these outlets that you want the building to turn off for you at the end of the day, so that you don't have to remember to do it. So this is not a requirement that all receptacles within a building need to be controlled, only a certain percent of them. And then it's not necessarily that the building is trying to control what you are doing and what you're using power for. It's more that these are there so that the building can help you remember to turn certain things off. Lastly, here in commercial lighting, there's a new requirement for electrical monitoring. This monitoring is similar to the fault detection and diagnostic requirements within the HVAC requirements that Ryan just covered. This type of monitoring is extremely useful in terms of troubleshooting and identifying failing control signals. So HVAC systems can identify if operation starts to drift from outdoor conditions. If we see exterior lighting on during the day or substantial interior lighting on overnight, this may indicate that we have problems with controls or sensors. Photo cells or even time switches may be having issues, or even problems with the receptacle monitoring can help to identify if plug load controls are not functioning properly or if users are defeating the plug load management, which may be possible. The data that this monitoring gathers needs to be held for at least 36 months. And again, this is another one of those requirements that's bringing ASHRAE in closer alignment with IECC 2021. So systems that need monitoring are HVAC systems, interior lighting, exterior lighting, receptacle circuits, large process loads, and building operations, and other miscellaneous building operations. And this requirement is only for buildings that are greater than 25,000 square feet. So if your project or building is less than 25,000 square feet, you do not need to install electrical system monitoring. If your building is larger than 25,000 square feet, you do need to install electrical system monitoring. All right, I believe at this point we have another poll question. So poll questions here are, where are occupant sensors required? Are they required in open office areas, warehouse storage areas, lobbies, library stacks, bathrooms, or corridors? And then question 2, what systems require electrical monitoring? Interior lighting, HVAC systems, plug loads, or large process loads?
All right. I realize we are already at time. I'm going to go ahead and do the residential provisions as well. But if you do have to go, we understand. And again, the slides and the archive recording of this will be posted to our website. So if you do have to run and catch this at a later time, you're able to. So do want to make sure I mention that. So residential, I'm looking at about 15. I'm going to try to get this in about 15 minutes. So see, we do have a question about air barrier testing for commercial buildings. It is for new buildings and additions. So depending on the addition, that could be a little bit of a challenge. But yes, new construction and additions. Just a simple renovation would not necessarily trigger that. And a question about equations, any official equations to convert between SEER and SEER 2. There are not, because there are two different testing methods. And so it's not just a direct conversion. It is based on how does that equipment perform based on the other, the new testing methodology.
Okay. Looks like I can go ahead and end this poll here so we can keep moving along. It looks like most people got the first question correct, that all of those spaces require occupant sensor controls. And then the second question here, what systems require electrical monitoring? Again, it looks like most people got that one right, that all of those different systems do require electrical monitoring if the building is above 25,000 square feet.
There was a little bit of a trick in this first question. Lobbies and library stacks were not.
You're right.
Yeah, so
My
a
mistake.
little bit of a tricky one there. But of the answers, those got the least votes, so that's good to see. Okay, So residential, got a few definitions. They did tweak circulation and demand recirculation systems on residential. Again, trying to update and bring that in alignment. It's more about what triggers the circulation system to start and stop rather than how do you deliver that water. So they did update that. Also added on-site renewables, renewable energy certificates, and renewable energy resources to the definitions for that. So a couple of new definitions, but nothing too major here. Roof recover. Again, this is something where understanding that this is where you are installing an additional roof covering over top of the existing without removing the existing roof covering. So that's something. Roof recover is different from a roof replacement. Also calling out that there's a new section to define air permeable versus air impermeable insulation. 0.004 CFM per square foot of at 75 pascals is where they draw the threshold. A lot of your foams are going to be impermeable. A lot of your other fibrous type insulations, be it fiberglass, cellulose, mineral wool, or things like that, is typically air permeable. So, as far as the residential compliance, noted here, prescriptive. You do have to add an additional efficiency package. We want to try to get a 5% improvement. If you are using the total building performance, this is not the UA trade-off that you find in ResCheck. This is an actual building energy model that you're doing. You can do this either. You either show that it passes and you do not model the extra compliance, the extra efficiency measure, or you go ahead and include that extra efficiency measure in your design and show that it has a 5% reduction over the baseline. So ERI is similar, need to add a 5%, need to get 5% better than what is listed in the table in order to achieve that. And also, as we mentioned, passive house certified, no additional requirements because that's going to be a high performing building already. As far as efficiency package options, so we've gotten a few different energy efficiency package. So if you're getting your extra 5%, so this is something where previously commercial buildings had to have an additional efficiency package. Now we're adding it to the residential. So either boosting your envelope performance, your HVAC, or better service water heating performance. You see 2.0 energy efficiency factor on electric basically says you're going to use a heat pump for your service water heating because in order to achieve a 2.0, that's not an electric resistance unit. You can have better efficiency thermal ducts for HVAC distribution. Oftentimes this may be done where all the ductwork is inside your thermal envelope, so we're not pushing energy to the outside. Can also do improved air sealing. So rather than having just the minimum standard, we're going to do some better air sealing and things like that. That's another efficiency package you can choose. Mentioning the total building efficiency. So if you're going to do this under the performance path, there are also a couple of added features, one of which is they added an envelope performance backstop to this requirement. So you can't just have any old envelope that you want and trade better HVAC equipment. There is a backstop. I believe it's the 2018 envelope provisions that you have to meet, regardless of if you're doing performance or not, in the 2021 IECC. The 2009 2009, you cannot have an envelope worse than the 2009 for the 2021 IECC, regardless of how you're getting there. ERI targets we see have changed dramatically from 61 and 62 down to 54 and 55. So for those of you who've been around for the last code cycle, you'll see this looks very similar to the 2015 ERI target. So they've moved that. And again, you have to show an additional 5% reduction in this ERI if you're modeling it with your efficiency package, or if you can use this as long as you don't include your efficiency package as part of your modeling, but you do go ahead and do it as part of construction. So, and the ERI backstop, if you want to use renewables to achieve these targets, then the envelope cannot be worse than the 2018 IECC for that. So I've added a little bit to the certificate. So added the PV information to the certificate. So if you do grab the certificate off our website, you'll see it has been updated with that new information for that. People can use a certificate even if it's an existing building. You just you fill in whatever you know. And that's actually good practice. So if you're going up into the attic, go ahead and take a note of that and write it on the certificate, such that as when someone goes to buy your home, they can begin to get a sense of, hey, this is better than average. This is a U factor table. Probably what people are more familiar with is the R value table. This is a huge change from 2018 to the 2021. You see, we're now seeing wood framed walls going up to, if all you want to use is cavity insulation, that's going to be an R30 cavity insulation. So that's going to be one thick wall for you. But they now have some additional, they now even show if you want to do just continuous insulation, R20 for that. We also do call out, because we do touch on some building science here, that FIAS and their investigations have noted for climate zone 5, be aware that R20 plus R5 continuous can have condensation and mold issues for that. So they do not recommend, don't use the 20 plus 5 because you have some issues with that assembly. Attic and doors, need to make sure that we've insulated those. Again, we've got interior versus exterior, making sure that we've insulated those properly. And they do call out as far as the hatch doors versus if you just have a vertical wall, vertical door and a knee wall. We see those often, or maybe from one side is finished and then you have an unfinished attic space that you'll see a vertical door, making sure that we're isolating those spaces. As far as floor cavity insulation, again, it calls out making sure that we're filling that cavity to touch such that we don't end up where you end up with air currents circulating, but within that cavity. So best practice obviously is just go ahead and do that full depth so that you don't end up with air currents in there. Basement walls. So if you do have, we get a lot of questions lately about basements and do they have to be insulated or not. If you'd have any conditioning in the basement, then that needs to be within the thermal envelope. If you have no conditioning in the basements, so that means all the ducts are insulated, any hydronic systems are insulated, no supplier return diffusers, then the basement can be outside your thermal envelope, but be aware that you're doing your insulation and air sealing, particularly on these stairwells going up, and that door is going to need to be insulated and weather stripped because again, you have conditioned versus non-conditioned space meeting. For sunrooms and heated garages, this is a little bit of a change. Previously, it just addressed sunrooms. Now it also includes heated garages. They have their own provisions for that, and they need to be thermally isolated. And then if you have the wall separating the home from the sunroom or garage, those still have to be fully insulated. So those are going to meet the full exterior wall insulation requirements, not the sunroom wall requirements. As far as piping, making sure that we're insulating that piping properly and air leakage. So being aware as far as this, we do not want class 1 vapor retarders on the being used as the air barrier on below grade walls. Again, we don't want to trap moisture inside these walls and cause them to mold and rot, because that's going to be a huge degradation. Also, being aware of rim joists, fibrous insulation is not good in rim joists. You do need a proper air barrier in those rim joist areas for that. And there was an addition of, if you've got narrow cavities, so if you've got less than 1 inch air cavity, then you don't necessarily have to insulate it, but you do need to air seal that. For those of you doing multifamily projects, there is air leakage testing protocols for that. Illinois previously had done an amendment to incorporate this, but it's now found in the 2021 IECC. This is going to be using enclosure-based area metric, 0.3 CFM per square foot at 50 pascals. It's a little different than the 0.4 at 75 that you find in the commercial. And these would be using an unguarded test. So you're doing these tests, you're having an open area between the areas. Which important thing there is we don't want air movement between spaces, which can bring odors and potentially sound with it too. If you do have electrical boxes in exterior walls, then they do need to be vapor barrier boxes. So this is, as Robert mentioned earlier, if your interior drywall is trying to be your air barrier, then you need to make sure that your box, all your electrical boxes are air barrier boxes and sealed properly and all of that. NEMA has come out with this OS4 standard, so you can look for that on boxes and specifying that. As far as ducts in unconditioned spaces, haven't changed anything here, but they now have a thermal distribution efficiency method that we can use for that. So being aware that that is there. As far as understanding if ducts are in conditioned space, if it's not obvious, then it does need to meet these requirements. Which also must require testing in order to show that it's 1.5 CFM per 100 square foot of floor area or less. Even if it's within the, if it's not obviously within the thermal boundary. The other thing is all duct testing is now going to be required. Previously, ducts only had to be tested if they left the thermal envelope. The new requirement is even if it's inside the thermal envelope. Now you do get a fairly high threshold of 8 CFM per 100 square foot as compared to 4 or 3 if they leave the building envelope. But the critical reason here is if the air is leaving the duct, and we did our manual D as required by the residential code, if the air left the duct, that means that air didn't reach the room it was designed to. So previously, everyone said, well, if it leaks, well, it leaked conditioned into the conditioned space. That's true, but it didn't get where it was supposed to. So, Illinois has proposed an amendment to allow a minimum threshold of 60 CFM, saying, as long as you got to you're not leaking more than 60 CFM, you're good, regardless of building size. So, as far as hot water piping, so piping 3/4, big change here is 3/4 of an inch and larger, even if it's in conditioned space. Previously, it only was the larger piping if it left the conditioned space. Also, they've clarified the circulation and recirculation systems. Those that use the domestic cold water line as a return, the cold water line doesn't have to be insulated because we're not introducing hot water into that line. Fans, fan efficiency, again, a little bit of just more rearranging here. Bath and utility fans have now just moved into other categories. As with the range hood, they kind of lumped it all together, and then integrated with HVAC equipment now has a minimum efficiency as well. For those of you who, again, helpful for those to grab the download of this, you can find out what the efficacy is on the Home Ventilating Institute website. They just have a nice database for you, CFM and watts, and you can do the calculation from there. Ventilation systems must now be tested. Particularly for like bathroom fans, there is an exception for your kitchen range hood if you do have at least a 6-inch duct and at most one bend, then those don't have to be tested. But what they were finding was people were buying 100 CFM bathroom fans. They weren't installed well, and because of how the ductwork went, they only got to move like 5 CFM. So saying, no, we need to actually test and verify, do these actually perform as installed? Ventilation rates, there's an amendment proposing to be able to reduce the mechanical ventilation rate if you're using a whole home ventilation system with balanced, that's a balanced ventilation system, and you're bringing all that ventilation directly to each of the bedrooms and at least one of the living areas, so living room, dining room, or kitchen. So understanding if you're distributing that ventilation evenly throughout the whole house, we'll give you a little credit for that. HVAC load and equipment sizing is still required, manual J and manual S. So you have to do your load calculation and then size your equipment appropriately for that. Anyone out there who is still using rules of thumb, 500 square foot per ton, that needs to leave, because that's what they're finding is code built homes anymore are now somewhere 1,000 to 2,000 square foot per ton of cooling is what they're now finding is required. But again, it's all depends on your home and your particular construction. So do that load calculation of manual J and then size it via manual S. There is also manual D that's called out for in the residential code, which is duct sizing. Purpose of that is to make sure the air that we've designed to deliver to a space actually gets there. Lighting, this has gone up. So it used to be 90%. We're now up to 100% of permanent lighting shall be high efficacy. So floor lamps and desk lamps and things like that don't apply. But this is a little different. As Robert mentioned earlier, for residential uses in commercial buildings, it's 90%. So if you're in a residential building, 100%, everything needs to be high efficacy. That's not a hard bar to achieve anymore. Most every product out there meets that. Something that may get a lot of pushback on is lighting controls. So for residential buildings, you need to have dimmer or occupant sensing controls or some other controls built into the fixture. For rooms other than bathrooms, hallways, exterior, and lighting for safety or security. So, all your kitchens, bedrooms, living rooms, dining rooms, all need to have dimmers or occupant sensing controls. So, new is exterior lighting. So if you have more than 30 watts of total exterior lighting power, then you need to have a photocell or time clock or a time switch with a override control function that may override for up to 24 hours. Mentioned earlier about FIAS. So if you are doing a passive house building, all you do is provide the documentation of here's the compliance features and here's my pre-certification letter. And that's all you need to provide as far as the certification documents for that. And then prior to the issuance of the certificate of occupancy, you'd provide your final project certificate. So do recommend that. That's very handy and easy to do as far as the paperwork on that side. Actually achieving that, that's a little bit harder, but it's good to, those tend to be very resilient buildings, which is good. Building additions, clarifying a little bit for change in space conditioning. There's a major, talk about that in a moment, but changes in space conditioning, they did clarify that a little bit. And the ductwork existing previously, if you were extending the ductwork less than 40 feet, you didn't have to test it. They've now removed that and said, no, if you're adding ductwork, test it. Alterations, again, very similar. So if you're adding ductwork, you need to test that. Change in occupancy. This is a major change that we are seeing. Previously, any space that was changing in occupancy that increased demand for energy you lost all your grandfathering and had to show that the full building complied with the energy code. They now have changed that to, if it is unconditioned or low energy space, changed into residential, then you have to bring that into full compliance. What this does is if you are converting single family into multifamily and being able to increase building population density like that, that previously would have triggered this and said, nope, you got to show full compliance. Now that is no longer the case for that. So now if you do, it's only if you've changed spaces from another use into residential, then you have to bring that into compliance. Performance, that's basically the same. Some helpful websites that are out there for local design conditions, and mentioned the standards and codes are available for viewing out there. And with that, I appreciate the rest of you who have been able to stick with us. One final poll. Which of the following are required by the Energy Code? Manual J, Manual S, Manual D, or Manual B. You can answer multiples of those. And for the second one, which domestic hot water piping in residential buildings must be insulated? So all piping, those serving multiple dwelling units, 3/4 inch lines and larger, circulation and recirculation systems. Questions as far as, okay, a couple of questions here. Any of the lighting levels or reduction in lighting take into account for security reasons? That is a primary reason for some of those where they have identified those that are already low lighting levels, and that reduction would cause a life safety issue. They've already taken that into account, which is part of the reason for like corridors. They call out that 2 foot candles per square foot, because if you cut that in half, you're at 1, and that's the minimum for safety. So that's why they've written that those into the provisions. But if it's not in the provisions, that's not in there. They do have some provisions where they will call out for safety and security, or several times they'll mention about healthcare spaces, specifically where patient care is directly provided. So it wouldn't necessarily be hallways, as that's not typically where patient care is provided, but that's part of where they get into with that. So let's see here. Let's see here. Acceptable for load modeling, such as carrier HAP or train trace. It is any software that is in compliance with IECC Manual J. Carrier HAP and train trace, I know typically are geared for commercial applications, but they may also have functionality that is in that may also meet the requirements of Manual J. So that would be a software specific question. IECC does have a speed sheet available on their website for free that you can use. Takes a little bit of getting used to, but that is another option out there. CDAC will report, yes, those attendees who have submitted their AIA number upon registration. We will go ahead and report that to AIA for you. And just a follow on or clarification on the FIAS, the issue with 20+5 insulation is you can have a condensation issue as moisture as vapor is passing through that R20. You will hit the dew point before it reaches the continuous insulation. So the dew point will be inside the cavity insulation and not in the continuous insulation is the concern there. So having condensing in there.
Yeah.
All right. Let's see here. We've got our which of the following are required by the Energy Code? Manual J and Manual S. Those are the two required by the Energy Code. Manual D is required by the residential. The IRC requires Manual D. Manual B is for balancing. That's not required by any code, but that would typically be performed by whoever's doing the duct installation and following your Manual D. Number 2, which domestic water piping must be insulated? Should be everything but the first one. So dwelling units, large lines, circulation and recirculation systems. There is some hot water pipes. So if you have small hot water piping that's not served by a circulation or recirculation system, that does not have to be fully insulated end to end. There may be the first few feet may be required to be insulated. I'm trying to recall my provision on that. But yes, so everything but the first one would be the correct answers. All right. Not sure if we've got any other questions. I've got one here. What is the trigger for when to add in ARC?
I believe that's for automatic receptacle controls.
Automatic receptacle controls. That is an excellent question.
Yeah, looking in the code, it does appear that it would be any project that has enclosed offices, conference rooms, used for primary or copy print functions, break rooms, classrooms, individual workstations, including those installed in modular partitions and modular work office workstation systems.
If I recall how that's phrased in the existing systems, it would be for if you are doing an alteration where you are going to be adding or changing receptacles, then you would have to add that control for those spaces. So it doesn't have any particular threshold, but if you're going to do modifications or alterations, you're going to need to add to that until you achieve the threshold. So if you're only changing 10% of the receptacles and you have to get to, I believe it's 50%. So those 10% that you put in, 100% of that will have to be receptacle controlled. So. Can electrical monitoring be done at the panel level, or does it have to be at the equipment level? They don't call out where it has to be done. They only call out what loads have to be done. So you are able to have as few as, I believe that's 5 categories, was it, or 6 categories?
Total HVAC system, interior lighting, exterior lighting, plug loads, process loads, and building operations or other miscellaneous.
That's 6.
Yep.
6. So you can do it with as few as 6 meters or as many as you need to be able to segregate that out. They do have provisions in there for some mixing of loads. So if you have, I have an entire receptacle panel and I have a circuit of lighting load that came out of that panel. I believe they do have some provisions in there to allow for that. But yeah, you don't have to necessarily go down to every little, you don't have to track every single circuit. You just have to make sure that all the different loads are tracked. And again, the important reason for that is we're trying to go after, do we have troubleshooting that needs to be done? Do I have exterior lighting that's on overnight or during the day that shouldn't be? Do I have a lot of people either leaving plug loads on and defeating or some of my receptacle control circuiting is not working properly? Or it may be just even some where you look at it and you say, occupants have control generally over lighting and plugs. So those are the two that I'm going to really, if I see those creeping up, perhaps I need to do a PR campaign to say, hey guys, let's get this back into check. Can it just be amps or does it have to be kilowatt hours? I can't recall off the top of my head what it says in the provision for that.
I will see if I can find an answer here.
So see, I know we got a few other questions that came through in the chat. We'll see what we can. A lot of questions in the chat here.
I am not seeing a reference to either amperage or kilowatts within the language.
Does it just say electrical monitors?
Yes.
Okay. Or
energy monitoring. Yeah.
Energy monitoring. So that would lean towards you would need kilowatt or kilowatt hour meters, amperage, because amperage would not be energy. However, that's where you get into that may be a jurisdictional question. Obviously, amperage is going to be generally easier, but or a little bit easier. Fortunately, we have seen electrical meters being dramatically more available and much cheaper. So may not be too bad, but part of that again is if you're able to segregate your loads, that'll make it a whole lot easier for you. Yeah, it looks like someone was answering that HAP and Trace don't have a manual J methodology. So
yeah, so that, and then we do have a question about credit since we went a little bit over. We'll have to see about that.
All right. Well, thank you so much. And again, if we did miss your question, then do email us energycode@illinois.edu. Question about potentially measuring amperage and then multiplying by voltage. They're saying it's fixed voltage, but it really isn't. We do see in in a lot of territories, they do a good job of keeping it in a fairly tight range, but we'll check. But yes, attendance, check your emails for your attendance certificates. That'll probably come out here within the week or so. Thank you all.
Yep.
Have a great afternoon.
Thank you.